The lesson of today, it is about functions and about analyzing the graph of a function. It's about analyzing the graph of a function. And as you see, I just draw here a function, the graph of a function, and we are going to find many important facts about this function. We are going to find, please you take a note at the same time, we are going to find the x-intercept, the y-intercept, we are going to find certain points on the graph, if it's there or not. We are going to find the maximum function, what's the value of the maximum function. We are going to find what's the minimum value of the function. We are going to find the so many different things, okay? Good. So, let me start first with the x-intercept. Are there any x-intercept? What do we understand by x-intercept? The x-intercepts are those points of the graph where it intercepts or just touches or passes the x-axis. So let us see. Do we have x-intercepts? Yes, we have. That's 1, that is 2, that is 3. So we have 3 x-intercepts. So one of them is -3. We always start from the left-hand side. It's -3. One of them is 6 over there. And one of them is 10 over there. So I need to be very careful, and I need to be able to read the graph. And also, of course, I can, as you see, also I can put the ordered pair, which means that at all x-intercepts, the value of y is always equal to 0. The function is 0. The height of the function is 0. Look at this point. There is no height, it's just lying over there. So, -3, y is 0. 6 and y is 0. Let me write down here 6. Always I put it like this. First the x-intercept, then the value of the y. And then finally the other one is 10 over 0. Let me go now to, now before I go further, is there any question? Is it clear to everybody what I'm explaining about the x-intercepts? Is it clear? Yes? Robin, is it clear?
Yes.
Good, thank you. So let me now go to the y-intercept. The y-intercept is that point of the graph where it intercepts the y-axis when x is 0, which means that when x is 0, is here x 0? No. -6, -5, all x has values. Here x is 0. So let me see. Is at this point the function is intercepting the y-axis? Yes. And this is where it is. So this is my y-intercept. Y-intercept, which is 0, 3. When x is 0, that's y-intercept. Is there any other y-intercept? No, there's no other y-intercept, because if there is another y-intercept, wow, it's not going to be a function. It's not going to be a function because it should cut only at one point, the graph. It can't go and then come back again. Because we learned that. We learned already. Good. So there's only one y-intercept, which is 0 at 0, 3. Now, another good question is, what is the value of f0? And some of us, we had trouble. We didn't understand this question when I gave you an assignment. What it means, f0 means what would be the value of the function when x is 0. The inside parenthesis means when x is 0. What's the value of the function when x is 0? Well, x is 0. Here is x is 0. what's the value of the function? What is it when x is 0? Well, let me see. It's 3, which is the y-intercept. In one word, that's the y-intercept. I just gave this extra question to let you understand that the y-intercept is when x is 0. So, f0 means it is 3. There you go. Y is 3. Another question is, what is the value of the function when x is 3? When x is 3. Let us see. When x is 3. Let me change this as, I don't have to, well, okay, let me go. Let me try. When x is 3, what do I need to do? What do I need to do? To find the value of the function, when x is 3, let me see, what is it? Wherever it cuts the function, there it is. That's the value, which is approximately 3.5. There you go. This is 3 and 3.5. That's the value of y. This is how I find it. This is how I analyze a function. I need to know what is the x, what is y. How can I find the value of y? All I need to do is just start playing with my pen, going horizontal, vertical. That's all I need to do. And of course, you are supposed to know this from your Algebra 2 class already. But still, I'm going to go over all those things. So F3 is almost 3.5. 3.5. Also, while I'm explaining this lesson, you can take some screenshots. You can take pictures so that you know what I'm doing. Because I will erase those and start something else afterwards. Now, the next one, F4. F4. Let me, Guerrero, David, Jacqueline, are you there? Jacqueline, what is F4? Can you tell me what is F4, please?
F4, is it 3?
Yes. When x is 4, let us see. Here it's 3. There you go. When x is 4, there's x is 4, this is x, and this is y. Always the first order pair shows x, and what's the value at that point? That's how we find it. That's how we find it. We look at the order pair, and then start going vertically up. 3. F negative 5. F negative 5. Who's going to tell me? What's the value of f negative 5?
-2.
Beautiful. F negative 5, here x negative 5. Let me bring a vertical line. There. When x is negative 5, y is negative 2. There you go. There you go. You see how easy it is? How easy it is to read the graph? It's just a game. It's just like a game. We're playing a game, guys. That's all. It's fun. There you go. Now, after doing this, we're going to find something else. Now, here, you see, this is f0, means when x is 0. When x is 3, find the value of the function, which is the y. Look at this one. The question here is, what is maximum fx? What is the value of your maximum y? Fx is your y. What is the value of your maximum y? Anybody can tell me?
4.
4. At what x it becomes maximum? What will be the value of x when y is maximum?
2.
Beautiful, beautiful, beautiful. So there you go. Your maximum y is 4. There you go. There you go. So this is the game we are playing today. This is the game we are playing today. So when x is 2, it looks here I have got my maximum value. Good. Now the second question. What is my minimum value of my function? What is it? What's the minimum? Yes? Yes?
-3.
Who was that?
是双星，
Jack, huh?
是双星。
Yes, yes, yes. Beautiful. It's -3. It's not -2, as you see here. It's not. My minimum is -3. Beautiful. You see, that's how you observe. You look at the graph. You look up, you look down, you look at the local minimum, you look at the absolute minimum. So the absolute minimum here is -3, and when x is -6. So I'm going to put it down here, which is -3. Now, the question is, do I have a local minimum? The local minimum is, it's not the absolute minimum, it's the smallest value of the graph at a certain I would say certain zone. In this zone, for example, do I have a local minimum? Yes, I have a local minimum. It's not the absolute minimum, but it's a local minimum, and local minimum is -2. This is local minimum. Let me write it down. Local minimum, which is the minimum at a certain point, is equal to -2. For example, I have students. I have 5 students sitting together, and let's say the shortest one, don't take it personal, the shortest one in that is, let us say, for example, David. So the shortest one. Then there is another one, but he's a little bit taller than, but he's shorter than others. So the shortest one is David. So David is the local minimum, -2, and maybe the next one, a little bit taller, is Jacqueline. Jacqueline, oh, sorry. David is the minimum, and Jacqueline is the second one in height. It's -2. Okay, that's another way of explaining you. Maybe it wasn't a good example, but it's okay. Good. So, do you have any question for me until now? Any question for me until now? Please, just think about it a second, if you have any question for me. Okay?
How do you get the local minimum?
How did I get the local minimum? How did I get the local minimum? Now look here. Look here. All this, below this, I have minimum. The function is getting minimum. But look here. I have one minimum here. Do you see this minimum, mister? Do you see this minimum?
Yes.
What's the value?
-2.
Good. But then below this, do I have anything less than this? Let me see below it. I don't have it in this section, but over here, I see it's getting less than that. What's the other minimum here?
-3.
So which one is less? Which one is less? -3. And I don't have anything below -3. So -3 is my absolute minimum, and the local minimum is -2. Get it?
Yeah.
Yes, that's what it is. Good. Now, another thing I want to go with you, something else. Let me see. I want you, please, tell me what is the domain of this function? That's another important question. What is the domain of this function? The domain is, we need to understand the domain. The domain is all those values of x all those values of x where the function has a value. Now, look here. Look here. If I go further to the left, does the function has any value? Do I have any values here?
Yes.
No, the function has stopped here. The function has stopped here. So the function on the left-hand side of this -6, it has stopped. There is nothing. So there is no domain there. There is no domain. The function has stopped. So from where the domain starts for this graph? From where it starts? From where it starts the domain? From?
-6.
-6. It starts from -6 and it's a solid dot, which means it's included. So the domain starts from here. The domain starts from -6. The domain starts, then the function continues. Whoa, continues, goes on, up and down. Then what happens here? What happens?
It stops.
It stops. That's the end of the domain. There is no value afterwards. If I go to the right, it's empty. There is nothing. The function is not moving. It's tired. It's sitting. It's so tired. It stops. There is no domain. So the domain for this function is, x is greater or equal than -6 and less or equal than 11. That's the domain. And for all those domain, I have values for x. When x is -5, I have -2. When x is -3, the function is 0. When x is -1, it's something. So I have always values for y. Always. But beyond this, on this side, beyond this, and beyond this, there is no value for y. It stopped. That's my domain. It's not -infinity to +infinity because it's solid. It stopped. That's it. Now about my function. What is the range? The range is the minimum value of y up to the maximum value of y within the domain. What does within the domain means, Jacqueline? Within the domain. Within the domain, it means I cannot try to find the value of y after this point. There is no sense of looking for y beyond -6. So my domain, what's the value of my minimum? What's the value of my minimum value of my function? What is it? What is it? What is it?
-3.
Huh? Yes, again? Go ahead. You were right. What is my minimum? Why?
-3.
Yes, -3. And goes up to where? What's my maximum range? What is the maximum height I gain? What is it?
+4.
+4. There you go. Up over here. Here, my maximum. So 4. And as you see, it's a solid line, so it's included. Y is greater or equal than -3, the height. That's the height. That's the height. That's y. And the other y is from here to here. And all my function lies between those 2 points. All my function goes up and down, goes increasing, decreasing, but it lies within this domain, within this interval. And we call this, the x domain, also interval of time. Within an interval of time, my function is swinging from here down up there. Is it understood now about the range and about the domain? Now, yes? Good. Now I'll give you one more question before I let you go. Let me see what else. Now, I'll give you one more. So let me just give you one more. Can I erase this? Can I erase? Did you take a picture, kiddos? Did you take a picture of it? Yes?
Yes.
Good. So please, I would recommend that always take a picture, record it or something so that you have it in your document, okay? So, watch. Now let me erase it and give you this following interesting question. Interesting question. Let me erase this. Now, I want you to tell me how many times the line y is equal to, let's say, mamma mia, y is equal to 1 intercepts fx. Let's read the question very well. And I want you to pay attention very well. Very well. How many times the line y is equal to 1 intercepts my function? How many times it touches the function? Look at it carefully. Think about the question. Don't answer something without trying to understand the question. How many times the line y is equal to 1 intercept the function? What do I need to do first? What do I need to do? Where is that line? Y is equal to 1. Where is it? Anybody can tell me? Y is equal to 1. Where is that line? Where is that line? Julie, where is that line? Julie, what is that line? What do you think? What do you think? Where is that line? David, what is that line? Y is equal to 1. There is y is equal to 1. This is the line. This is y is equal to 1. So how many times it intercepts my graph? That's once. That's
3 times.
another time. And there it's 1. My goodness. Bingo. 3 times. Do you see what type of question it is? It's a question for you to think about. How many times it first lets you understand the line y is equal to 1, which means that always y is equal to 1. Y is equal to 1 here, y is equal to 1, y is equal to 1, that line, that horizontal line, y is always equal to 1. How many times it touches the graph? 1, 2, 3. 3 times. Okay, guys? How many times the line y is equal to 3 touches the graph? How many times? Y is equal to 3. How many times? Look at the graph. Y is equal to 3. How many times?
2 times.
2 times. 2 times. Beautiful. 2 times. Everybody got it? Understand, everybody? It's 2 times? Yes? Yes. Now, the last question. How many times the line y is equal to negative 3, how many times it touches the graph? Y is equal to negative 3.
1 time.
Beautiful. There you go. Now you know how to read the graph. Now you know how to read the graph. Was it a good lesson, this one, for you to understand? A good lesson. The last thing before I let you go once again is because I had some students, they did not understand about this. Y is equal to 2x plus 6 plus 6. What is the domain? What is the just show me what's the domain. Which one shows you the domain? Which one? X is the domain and the range, Y is the range, and many they put this answer wrong. X, the variable, X, that's the domain. But if I ask you, well, tell me please the intervals of the domain, then you say X can have any value between negative infinity to positive. That's another question. What's the range? The range from negative infinity to positive infinity. But in this case, what's the domain? X is the domain. Y is the range. Okay? Please, thank you so much. Cordero, Talia. Who is this? Talia? Okay, good. So I hope that you don't have any question. I will just post the same video on your page today. Okay, so I will let you get this time, or you may continue your classwork at this time. At any time, you can refer back to anything that I posted to you. And please, I just want you to know that your assignments, this one, they are due on Saturday. You see how many days I gave you? Wednesday, Thursday, Friday, Saturday, 4 days. Your class is good, I know, but please just post your assignments before due date. So I will let you go. You may continue your work at this time. Okay? Thank you. Thank you, everybody.
Thank you. Bye, Mr. Sam.
Do you have any question for me? Do you have any question for me?
No.
Yeah, if you have any question, just let your question, give it to me after tomorrow again. Okay? Bye, guys. Have a nice time. Bye-bye.